Welcome back to the Chapter 11 Algebra 2 Tricks Study Guide. So we are starting on number 5. Number 5, it first says to find the inverse of the system. So remember, we set this up using the coefficients in front of our variables. So we have -1, so -1, and then in front of my x down here, I have a 1, and then 2 in front of my y, and a -4 in front of my bottom y. So it's just using those coefficients in front of the variables. So -1, 1, 2, and -4. That's where we got all of these numbers from. And then on the right side, we're going to put no, I cannot think of that word. So we're just going to put the 1, 0, 0, 1. Wow, having a blonde moment here. That's okay. Okay, so my goal is to first get a 0. Remember, 0, then a 1, then a 0, then a 1. No more than that. So what I am going to do is I can really get a 0 anywhere to start with. I am going to start by getting a 0 here in this lower left-hand corner. Whew, I'm having a rough time here. Okay, so it's already at -1 and 1. They're already opposite, but the same number. So we have 1 and -1. So when I add those two numbers together, it's going to get me 0. So -1, 2, 1, and 0. 1, -4, 0, and 1. So we add. So -1 plus 1 is 0. 2 plus -4 is -2. 1 and 1. Okay, so now that I've gotten my 0, I need to get my 1. Remember, to get a 1, you do that by division. So I'm going to divide everything through by -2. Because I want a 1 right here. And the only way to do that is by dividing it by itself. Because we divide one number, we have to divide the entire row. So I get 0, 1, -1/2, and -1/2. Okay, so I am going to rewrite it. Now, 0, 1, I want that in the bottom. So my first one, -1, 2, 1, 0. That first row is going to stay the same. And my new row, 0, 1, -1/2, -1/2, is going to go in for my second row. 0, -1/2, -1/2. Okay, so I got a 0 by adding two rows, and then I got a 1 by division. So now I'm going to get a 0 again. So now what I want is I want a 0 up in this corner. And so I look at my numbers. I have 2 and 1. So since they're not the same, I want them to be the same. So I can make 1 into a 2 by multiplying it all by 2. Now remember, I want them to be opposite signs, so I'm going to multiply the entire bottom row by -2. Top row stays the same. -1, 2, 1, 0. My bottom row is going to become 0, -2. -2 times -1/2 is 1. And -2 times -1/2, 1 again. Follow through. Okay, so now we can add -1, 0, 2, and 1. So now, again, I got a 0. Now I want this to be a 1. So to get that to be a 1, I divide everything by -1. And I get 1, 0, -2, and -1. I'm going to continue my work up here. So now I have my bottom row was perfect. So 0, 1, -1/2, and -1/2 was good. That's what I wanted. And so now my top row, I'm going to replace that with what I got down here. So 1, 0, -2, -1. And so now on this side, I have what I wanted. I have my 1, 0, 0, 1. And so what that means is this side is my inverse. So my inverse is -2, -1/2, -1, -1/2. And that does it for part A. Now, with part B, it says use the inverse to solve the system of equations. So what we do is we take the inverse, -2, -1/2, -1, -1/2, and we're going to multiply it by the solutions to each equation. So -10 and 12 are going to go here. Okay, so remember, when we are multiplying two matrices together, we're going row by column. So row, -2, times -10, plus, I move over and I move down. So plus -1 times 12. Now I'm going to move down in my row, so that means I'm going to move down in my row over here. So -1/2 times -10 plus -1/2 times 12. Now notice these second numbers always are aligned. -10, -10, 12, 12. That's how it should always be when you're multiplying. So we get 20 plus -12, which gets me 8. And then we get 5 plus -6, which is -1. And so 8 is my x value, -1 is my y value. So 8, -1 is my answer. Okay, so on to number 6. Number 6 is a 3 system with 3 variables. So with this one's kind of different. It has 8x minus z, y plus z, 11x plus y. So all of these actually are 2 variable equations, but they all have different variables. And remember, we're looking to get 2 equations that have 2 of the same variables in it. And none of these actually do. So what I'm going to do is I'm going to use 2 of my equations to get another equation that has x and y. I could use any 2 and get any 2 variables, but this is just going to work out. That's the way that I kind of did it. So I'm going to rewrite them first because I like to have my room over here. Okay, so what I'm going to do, and really what I noticed was if I add my top 2 equations, I will automatically get rid of the z's because I have a negative z and a positive z. So 8x minus z equals 4, and y plus z equals 5. So now all that I have to do is combine my like terms. Now 8x and y can't combine, so I'd bring down 8x plus y. Negative z plus z, well that cancels, and then now it equals 9. Okay, so what I notice here is that I now have 8x plus y equals 9, and I have 11x plus y equals 15. So I have 2 variables with 2 of the same equations, or 2 equations with 2 of the same variables involved. So I'm going to replace my top equation with that one. So I am going to put 8x plus y equals 9. The reason why I kept this one is because it's, there's no variables or no constants in front. It's just pretty basic, so it's easy to kind of manipulate or plug things into. And I didn't touch the bottom one, so that one stays the same. Okay, so 11x and 8x, well, let's move and look at our y's. So our y's, +1, +1, so those make it really easy to eliminate. So I'm going to multiply my top equation through by -1, and I have -8x minus y equals -9, and then this one's going to be 11x plus y equals 15, and I'm going to add them. So Negative 8x plus 11x gets me 3x. My y's cancel, and negative 9 plus 15 gets me 6. I take 3x equals 6, divide by 3, and I get x is equal to 2. So now at this point, I can plug it back in. I can either plug it back into my top one or my bottom one, because they both have x's in them. I'm going to plug it into the top one. So 8 times 2 plus y equals 9. 8 times 2 is 16. 9 minus 16. 9 minus 16 gets me negative 7. And there's my answer to y. And then my last variable that I need to get is z. So I'm going to plug it in. Y plus z equals 5. And so y plus z equals 5. Add 7 to both sides, and I get z is equal to 12. So I have my answers. I can check my work by plugging them back into every single equation to make sure it works. But I know it's the right answer, so we're going to write it as an ordered pair. So 2, negative 7, 12. Negative. So remember, you go x, y, and then z. Okay. I am going to do number 7 on a separate piece of paper just to kind of give me some more room. So we're going to start off with number 7. Now, your first thing that you're going to do with number 7 is get rid of one of the variables. It doesn't matter which variable you get rid of. It can be x, y, and z. Now, I know that most of the problems I've been doing z, but on this one, what I'm going to do is just kind of shake it up a little, and I'm going to do y. So what I'm going to do is I'm going to look. I have y, 2y, and negative y. So the first thing I'm going to do is I'm going to add my top equation and my bottom equation. Now, because it's positive y and negative y, I don't have to multiply them by anything. So they will just stay exactly as is. So 3x minus 2x gets me x. Y minus y cancels. 3z minus z is 2z. And negative 2 plus 3 is 1. Okay, so I am going to replace my new equation, x plus 2z equals 1, with my top equation. So for my top equation, x plus 2z equals 1. And then the bottom two will stay the same. 6x Okay, so now I have one equation with an x and a z. So that means that now I want to get another equation with just an x and a z. So what I want to do is eliminate my y's again. So I have 2 and negative 1. So that means I want to multiply my bottom equation by 2. So the top one's going to stay the same, 6x plus 2y plus 9z equals 5. And then my bottom one's going to multiply through. Remember, multiply everything through. So negative 4x minus 2y minus 2z equals 6. And now I can add. So 6x minus 4x is 2x. 2y minus 2y. Y's get eliminated. 9z minus 2z is 7z. And 5 plus 6 is 11. So I am going to replace my second equation with my new equation. So my top and bottom are going to stay the same. So x plus 2z equals 1 stays the same. And now I'm going to put in my new one. 2x plus 7z equals 11. And then the bottom one stays the same too. Okay, so at this point, what I'm going to do is I am going to eliminate I'm going to use my top two equations to eliminate either my x or my z's. Now, because I have x and 2x, and then 2z and 7z, to me, it makes more sense to start off by getting rid of the x's. So I'm going to multiply this through by negative 2. So negative 2x minus 4z equals negative 2. And then my second one's going to stay the same. 2x plus 7z equals 11. Okay, so negative 2x plus 2x cancels. Negative 4z plus 7z gets me 3z. And negative 2 plus 11 gets me 9. So divide everything by 3, and I get z is equal to 3. So now that I've solved for one of my variables, all I have to do is just start plugging things back in. So I'm going to plug in z into my top equation. So x plus 2 times 3 equals 1. So x is equal to negative 5. And then now that I have x and z, I can plug it into any one of my original equations up at the top or this one, which is still original equation. So negative 2 times negative 5 minus y minus 3 equals 3. So 10, 7. So subtract 7 from both sides, and I get negative y. Sorry, you got cut off there. Negative y equals negative 4. Divide both sides by negative 1, and y is equal to 4. Okay, so now my answer is just negative 5, 4, and 3. Again, check it by plugging it into every single equation from the beginning, and if it works out, then you did it right. Okay, so I am going to stop here and continue on with the next problems on the next video.